Have you ever wondered what would happen if we could move at the speed of light? Well, before we dive into that fascinating thought, let's first get a grasp of what we're dealing with here. The speed of light is not just any ordinary speed, it's a fundamental constant of nature, a cornerstone of our understanding of the universe. Imagine this: light, in a vacuum, travels at an astonishing speed of approximately 299,792 kilometers per second. To put it into perspective, it's like traveling around the Earth's equator almost 7.5 times in just 1 second. Quite mind-boggling, isn't it? This speed is so immense, so unfathomable, that nothing in the known universe can travel faster. It's the cosmic speed limit, if you will. Now let's ponder the question: what would happen if we could move at this incredible speed? To understand what would happen, we need to delve into Einstein's theory of relativity. Now, the theory of relativity, in essence, is a framework that describes how the laws of physics work when you're moving at high speeds. It's divided into two parts: special relativity, which deals with objects moving at constant speed, and general relativity, which expands this to include objects that are accelerating. At the heart of this theory lies the concept of space-time. Imagine space-time as a fabric, a four-dimensional tapestry woven from 3 dimensions of space and 1 of time. Everything in our universe, from the smallest particle to the grandest galaxy, exists within this fabric. And just like a ball resting on a stretched sheet, massive objects warp this fabric, creating what we perceive as gravity. Now here's the kicker. According to Einstein, the speed of light is the same for all observers, no matter how fast you're moving. This leads to some mind-bending conclusions. One of them is time dilation, the idea that as you approach the speed of light, time slows down. It's not just a theoretical concept either. We've tested this with incredibly accurate atomic clocks on jet planes, and it turns out Einstein was right. So, how does this relate to moving at the speed of light? Well, as your speed increases, the time dilation becomes more and more pronounced. At the speed of light, time dilation reaches its extreme. Time, as we understand it, would cease to exist for you. You would be frozen in a timeless state, while the universe outside carries on. This leads us to a breathtaking conclusion. If you could somehow move at the speed of light, you would exist outside of time. Every second for you would be an eternity for the universe. But remember, this is purely theoretical. The energy required to reach such speeds is currently beyond our grasp. So, if we could move at the speed of light, time would effectively stop for us. But could we ever achieve this speed? Let's consider the energy required. In the world of physics, nothing is as straightforward as it seems. To understand the energy needed to propel an object to the speed of light, we need to delve into the concept of relativistic mass. As an object moves faster and faster, its mass doesn't remain constant. Instead, it grows. This might seem counterintuitive, but it's a fundamental aspect of Einstein's theory of relativity. When you push an object, it accelerates. The more force you apply, the faster it goes. But as it picks up speed, its mass begins to increase. This is known as relativistic mass. The faster the object goes, the more its mass increases. And as its mass grows, it becomes harder and harder to accelerate. You need to apply more and more force, hence, more and more energy. This is where the speed of light comes into play. As an object nears the speed of light, its mass becomes closer and closer to infinity. It's a little like trying to reach the horizon. No matter how far you travel, it always seems just out of reach. As the speed of the object nears the speed of light, the energy required to push it even faster approaches infinity. To give you a sense of scale, let's consider a small object, say a baseball. If you were to accelerate this baseball to just 1% of the speed of light, you'd need the energy equivalent to about 60 Hiroshima atomic bombs. Now imagine the energy you'd need to reach the full speed of light. This is the reality of our universe, a reality governed by the laws of physics. It's a reality that tells us that no matter how much energy we have at our disposal, it will never be enough. The speed of light represents an insurmountable barrier, a cosmic speed limit that cannot be broken. This means that to reach the speed of light, we would need an infinite amount of energy, which is impossible. What about the physical implications of moving at the speed of light? Let's dive into this fascinating topic. Firstly, consider the extreme forces that would be acting on the human body while moving at this colossal speed. Picture this. It's like the world's most intense roller coaster ride, but 1,000,000 times more extreme. The human body simply isn't built to withstand such forces. Even at a fraction of the speed of light, the G-forces would be enough to render us unconscious. But that's just the start of our problems. At such high speeds, we'd also need to worry about radiation. Even in the vacuum of space, there are still tiny particles that would be incredibly destructive at light speed. These particles would hit us like a barrage of microscopic bullets, shredding our cells and DNA. Not a pleasant thought, is it? Additionally, there's the issue of time dilation, a concept we've learned from Einstein's theory of relativity. As we approach the speed of light, time would slow down for us relative to the rest of the universe. This means that while we might feel like we're traveling for just a few minutes, years, decades, or even centuries could pass by in the rest of the universe. It's a bit like a one-way trip into the future, with no way to return. And let's not forget about the heat. Even in the cold void of space, moving at light speed would generate an immense amount of heat due to friction. This would be enough to incinerate us instantly. There's also the small matter of energy. As we've learned, it would require an infinite amount of energy to accelerate anything with mass to the speed of light. This isn't just a minor technical hurdle, it's a fundamental law of physics. So, when we add all these factors together, we find a rather sobering conclusion. The human body, indeed any form of matter as we know it, simply could not survive moving at the speed of light. So, physically, it's clear that we cannot travel at the speed of light. So, what does all this mean for us and the universe? Let's take a step back and look at the grand picture. We started our journey by understanding the speed of light, a mind-boggling 700 million miles per hour. We then delved into the theory of relativity, proposed by the genius Albert Einstein, which tells us that as we approach the speed of light, time slows down for us relative to an observer standing still. From there, we moved on to discuss the enormous energy requirements to reach such colossal speeds. We learned that according to Einstein's most famous equation, E equals mc squared, the energy required increases exponentially as we approach the speed of light. This makes the feat of reaching light speed currently impossible with our existing technology and energy resources. We also touched on the physical implications of moving at the speed of light. We talked about length contraction and time dilation, mind-bending consequences of high-speed travel. We learned that if we were to travel at the speed of light, we would experience time at a standstill while the universe around us aged rapidly. So, what does all this mean for us and the universe? Well, the speed of light sets the cosmic speed limit. It frames our understanding of how we perceive time and space. It's the reason why we look up at the stars and see them not as they are now, but as they were thousands, millions, or even billions of years ago. It's why we can study the universe's past just by observing distant celestial bodies. The speed of light also sets a boundary on our ability to explore the cosmos. As much as we'd love to hop in a spaceship and zip around the universe at light speed, the physical and energy constraints make this a daunting, if not impossible task. But don't despair. These constraints also open up fascinating possibilities. By understanding the speed of light and its implications, we can start to think about ways to work around these limitations. Concepts like wormholes and warp drives, though still largely theoretical, offer tantalizing possibilities for future space travel. They give us hope that we may one day be able to explore distant stars and galaxies, not by breaking the light speed barrier, but by bending the rules of space-time itself. Lastly, the speed of light gives us a profound sense of humility. It reminds us of our place in the universe. We're part of a vast cosmos, bound by the laws of physics, and yet capable of understanding these laws and pondering the mysteries of the universe. It's a testament to the power of human curiosity and intellect. While we may never be able to move at the speed of light, understanding this concept gives us a deeper appreciation of the universe and our place in it.